Hello, my name is John Kelly. I'm the creator of the Weber Auto YouTube channel, and in this episode we are going to discuss the difference between a standard four-wheel drive transfer case and a center differential transfer case. So to begin with, I've got a couple of components from a standard four-wheel drive transfer case like you would find in any full-size pickup truck four-wheel drive. And what I want to point out as far as the difference between a center differential transfer case and a regular transfer case is the power flow. So I've got two pieces here. This is the input shaft to the transfer case. The automatic transmission or manual transmission output shaft is going to come in here and send power to this input shaft. This is the output shaft of the transfer case, and it's where the flange or the slip yoke of your propeller shaft is going to connect and propel the vehicle. So I want to show you that these two pieces are hooked together. So here's our input shaft, here's our output shaft, but I want you to see that there's no physical connection between those two. Let me zoom in here just a little bit so you can get a better view of what's going on. So we've got the input shaft, we've got the output shaft. On a regular four-wheel drive vehicle, without the center differential transfer case, we have two shift forks. One of them is called a range shift fork, and it's going to move this range sleeve in and out to give us four-wheel drive high, two-wheel drive, or four-wheel drive low. And then we have a mode fork that'll move this shift sleeve back and forth to give us the two-wheel drive mode or the four-wheel drive mode. Well, let's see how those are accomplished. If we take this range sleeve, it's going to spline from this hub, this clutch hub, back here to this sun gear hub that's part of the input shaft. And it has blind splines, and so it only lines up one way on this particular transfer case. This transfer case is out of a 2013 Toyota Tundra. Some transfer cases do not have a blind spline, and you can just line it right up and get the sleeve to fit on with no problem. But this one's tricky, so you got to find the right teeth. There we go. Okay, so I've got that on. I'm going to put the input shaft back on it. Okay, so we've got a range fork that's going to come in here, and it can move this sleeve all the way back and connect the output shaft to the input shaft. And notice now everything turns. If we turn the input shaft, the output shaft, let me put the flange on here so it's a little more obvious. If we turn the input shaft one turn, the output shaft turns one turn. But on a lot of transfer cases, there's a neutral position where this shift sleeve is moved to disconnect the input shaft from the output shaft. So now the input shaft is spinning, nothing's happening with the output shaft. And then there's a four-wheel drive low range that involves a planet carrier. This particular one is a 6-pinion planet carrier. Little bearing just fell out there. And then in the housing of the transfer case is the big ring gear that this sits inside of. This gear right here on the input shaft is the sun gear. And so what happens is the planet carrier sits up in here like this. Whoops, we're missing a piece. We have to have this piece with the planet carrier. It's the front of the planet carrier that allows that shift sleeve to connect with it. There we go. Looks like I've got to put that on before the input shaft. There we go. Okay, so I've got the planet carrier. I'm going to get it splined to the sun gear on the input shaft. Notice the planet carrier is just free to rotate. This little adapter connects to the front of the planet carrier. Excuse me, has some teeth on the inside of it there that allows this shift sleeve, when the shift fork pulls it out to this position, to engage the planetary gear set. And now I'm going to have my hand pretend it's the ring gear of the planet carrier and roll these pinions around. But if I rotate the input shaft, got so much oil on it. Okay, let's rotate the input shaft. I'm going to rotate the input shaft one full turn, and let's watch the output shaft. I want you to notice that we do not get there. We got a full turn right there of the input shaft. We did not get a full turn of the output shaft. As a matter of fact, these gear reduction ratios in four-wheel drive low are typically like on this model, 2.64 turns of the input shaft to 1 turn of the output shaft, or 2.72 turns of the input shaft to 1 turn of the output shaft. The Jeep Wrangler has an optional transfer case with a 4-to-1 reduction in the transfer case for a really, really low four-wheel drive low. So once again, this shift sleeve here, if we move it all the way in, gives us a direct connection, input shaft to output shaft, 1 turn. If we move it to a middle position, right here, then we are in neutral. There's no power flow. And if we move it all the way out to a third position here, then we have gear reduction taking place of 2.64 turns of the input shaft to 1 turn of the output shaft. So that's for low range and high range in four-wheel drive. But we're still, if power is only coming in and going straight out the output shaft, that goes to the rear axle, and that's two-wheel drive. So we need to see how to throw four-wheel drive in there. So now we've got another shift sleeve, and have to pay attention to which way it goes on. It has tapered teeth on one side, flat teeth on the other. We want the tapered teeth of the sleeve to mesh against the tapered teeth of the gear that it needs to connect with. That way it completes the shift easily. This is also the shift sleeve also has a blind spline This one's easier to match up. So let me get that up on this hub here. Of course, it's always easier said than done. Oh, come on. There we go. All right. Got that on. Pardon me. Okay, now I've got the output drive gear for four-wheel drive. Right here, that I'm going to put on to our output shaft. There's a big bearing up inside of there. There we go. So we have that output gear on there. This output gear right here is what the drive chain connects to, and then connects to the front output gear. So we've got the front output shaft for the front propeller shaft connected to the chain. The chain then goes around this gear. So if this gear rotates, then we are in four-wheel drive. But notice right now with this shift sleeve back or towards the front of the vehicle, in this case, even if we're in four-wheel drive high or four-wheel drive low back here, there is no power flow. Whoops. Let me get this block back up here. There is no power flow through, let's see, that's neutral. Let's go to two-wheel drive or four-wheel drive high. There is no power flow through the front drive chain. So the output shaft for two-wheel drive will turn, but notice the drive chain gear does not turn. And that will not turn until we take another shift fork and move this shift sleeve forward, or to the rear of the vehicle, sorry, to connect those two together. Now, these gear teeth here on the shift sleeve and gear teeth on the front drive gear, they have to be synchronized. The speed of those gears has to be synchronized, and so there's a special triple cone. It's an amazing synchronizer here, and the job of a synchronizer, and this goes in between these two, is to make these two, this hub and this gear, rotate at the same speed so that this shift sleeve can just slide over, because this is called shift on the fly. Anytime you're driving down the road in two-wheel drive, you should be able to hit a button or pull a gear lever and shift into four-wheel drive. Some vehicles have a maximum speed limit at which they'll allow you to do that if it's a push-button electronic control transfer case, but without a synchronizer, you would not be able to shift in and out of four-wheel drive high on the fly. Now, the four-wheel drive low shift does not have a synchronizer on most transfer cases. And so to shift in and out of four-wheel drive low back here, you must have the vehicle stopped, and you have to put your transmission, automatic or manual, in neutral so that this shift can complete, because there's nothing to synchronize the speed of the input shaft to the output shaft. So you have to be stopped so that they are synchronized. When you're stopped, they're both gears are stopped, and so they're automatically synchronized. But to drive down the road, this gear gear that drives the front chain is stopped as you're driving down the road in two-wheel drive. So this output shaft could be spinning 2,000, 3,000, 3,500 RPM. This gear is stopped. And so we need a really good synchronizer to speed up this gear to match the rotational speed of this output shaft. Now, if you think about it, to turn this gear, we also have to turn this chain and the front output shaft. That front output shaft is connected to the front drive shaft of your truck, which connects to the pinion gear, which has to turn the ring gear. So to turn this at all means that all of those parts have to rotate. That's why it's important to have the front differential oil be the proper oil. You don't want to just throw any old oil, gear oil, in that front differential. Typically it calls for a synthetic gear lube. And the synthetic gear lube, especially in cold weather, will not be as thick in viscosity. It'll be more fluidic, which will allow these gears to come up to speed more quickly than if you had just your traditional 85 W90 weight gear oil in the front differential. So you've got to have the right oil in the front differential in the first place. Okay, so to shift, right now we're in two-wheel drive. Front output shaft, gear drive, chain drive is not engaged. To shift into four-wheel drive, we take the mode fork, we move it to engage the drive gear, and now everything spins together and we're in four-wheel drive. Once the transfer case is in four-wheel drive, then you can engage the front differential into four-wheel drive. A lot of front differentials are disconnecting differentials. They have an electric motor with a shift fork that disconnects typically the right-hand axle shaft from the differential side gear. You can't shift that in. You can't actuate that front actuator or front axle without having the transfer case in four-wheel drive first. And then, of course, to come out of four-wheel drive, you do the opposite. You take it out of four-wheel drive on the transfer case and release the front axle. So this is a traditional four-wheel drive truck transfer case. This particular one is a Toyota, but it could just as easily be a Borg Warner, a New Process, a Magna Powertrain. There's a lot of different ones out there, but if you take enough of them apart, you'll see that they all have a planetary gear set of some sort to give you low range, four-wheel drive low. They all have a synchronizer assembly of, this one's a triple cone one. Some of them are just double cone. The more cones, the more synchronizing areas, so the faster it will synchronize to shift you into four-wheel drive and out of four-wheel drive. So we're out, now we're in, on the fly as you drive down the road. But the problem with a traditional four-wheel drive is that when you are in four-wheel drive on the transfer case, that locks the rear output shaft and the rear propeller shaft and the rear tires to turn the same speed as the drive chain and the front output shaft. And that, if anyone of you have driven a four-wheel drive vehicle and put it in four-wheel drive on dry pavement, you know that the powertrain binds and bucks and kicks, and it does that because you're trying to make all of the tires turn the same speed, when in fact they cannot turn the same speed when you turn corners. The left and right tires turn different speeds, and the front and rear tires turn different speeds. So this brings us to the next style of transfer case that this episode is about, and that is the center differential transfer case. The center differential transfer case has these same components. It has a planetary gear set. Most of them do. If it has a four-wheel drive low range, it still has a mode fork and a mode sleeve and a drive chain to engage and disengage the front differential into, or the front drive chain and the front propeller shaft into a four-wheel drive locked mode. But there's also what's referred to as an all-wheel drive mode. So a transfer case that has an all-wheel drive mode typically will have one more planetary gear set right here in the middle. And so I'm going to show you that planetary gear set style transfer case power flow next. Okay, we are now looking at a input shaft over here and an output shaft from an open, I'm sorry, not an open, a center differential transfer case. But a center differential transfer case acts like an open differential in a rear axle. And anyone who's ever messed with an open differential transfer case, if you lift a vehicle up on a hoist and the vehicle is in park and you turn, let's say, one of the rear wheels forward, the other rear wheel spins backwards. And the reason for that is the left and right hand axle shafts of the truck or car spline to the side gears. And since the ring and pinion are stopped because the transmission is in park and it stops the ring gear from turning, if you turn one side gear forward, then through the differential pinions that some people call spider gears, it forces the other side gear to turn backwards. So that's why a vehicle's tires with an open differential, one spins forward, one spins backwards. Now, if you have a limited slip differential, that won't happen typically unless it's really worn out. You'll spin one tire forward, or you'll try to spin one tire forward and it won't spin because the other one wants to spin forward also, and it can't because you are in park, and it would try to drive the drive shaft at the same time, and it would not be able to. Well, think of a center differential transfer case as acting just like an open differential. We've got the power flow coming in. Think of this as the power flow from the ring and pinion gear set. And then we have two outputs. We have this output shaft that goes straight to the rear axle, and then through a drive chain and gear, we have another output that goes to the front axle. The front axle and the rear axle are able to, or propeller shafts, drive shafts, are actually able to turn at different speeds due to a special component I'm going to show you here in this center differential transfer case. So let's take a look at the pieces involved here. So once again, we've got our input shaft, we've got our output shaft. Here's our output shaft flange. This is off of like a Toyota 4Runner. This was a vehicle that we had here. I think it was a 2004 4Runner, but it said all-wheel drive on the door. And so in just about any vehicle that's all-wheel drive is going to have some sort of a center differential transfer case. And center differential transfer cases are different because they have an additional planetary gear set. So the additional planetary gear set on this model is right here, and it's all enclosed in this housing. You can't see it very well. Well, you can't see it at all unless you unless you take it apart. And on this particular model, it has been disassembled, so I want to show you the pieces here. There we go. Okay, so we have a big open housing here, and inside of that big open housing, and it has some gear teeth here, it has, let me lift up this little sleeve here, get this gear out of the way. The equivalent of a ring gear from a planetary gear set. A thrust washer. And then notice in this carrier here, we have what kind of look like planet gears of a planetary gear set, but this is actually a design based on the original Zexel Torsen limited slip differential. And what we have here is the inner set of splines is going to drive, I believe, the rear output shaft. And then the outer set of splines here ends up connecting to the drive gear and chain and the front drive shaft. And so as this thing rotates, it operates, and it, of course, has a sun gear down the middle here. So we've got a sun gear, we've got planet gears, we've got a ring gear. This is a planetary gear set, but on a Torsen style differential like this, and they have these in rear differentials, they have these in front differentials. It's a high performance differential. Think of this as not only a planetary gear set, but it acts like a limited slip planetary gear set. So a high performance vehicle will typically have a limited slip differential. This will act like a planetary gear set or an open differential, but if you force it to spin too much, the speeds of the rear output shaft versus the front output shaft, if the speed difference is too much, then these gears have binding actions that force some of the gears down, some of them up into these thrust washers. There's one in the top here, there's one in the bottom. Every other one goes up, one goes down, and it basically acts like a brake. It slows down. It doesn't do a complete lock, but it slows down and tries to lock the two output shafts together. So in other words, as you're driving down the road, if the rear tires break loose, if we did not have this limited slip style, Torsen style planetary gear set in this transfer case, the rear tires can break loose on this center differential type of transfer case, and the front tires just sit there and don't have any power put to them. It's like an open differential on a rear axle. If one tire loses power, it sits there and, or not loses power, if it loses traction, it sits there spinning while the tire that has all the traction doesn't do anything. And so we want to slow down the tire that doesn't have traction and connect it to the tire that does have traction. That's what this does, except with the front and rear drive shafts. So if the rear axle lost traction and the rear tire started spinning, the front tire or front axle has not lost traction. This will slow the rear drive shaft down and try to make it connect to the front drive shaft, which transfers power to the front drive shaft, which will help pull you out of whatever situation you're in. That's the all-wheel drive setup. Now, this is an older style solution to that problem. The newer style ones don't use the Torsen limited slip feature in the transfer case. They just have an open differential transfer case. So this is just an additional planetary gear set. And then instead of using the limited slip action in the transfer case to provide power to the front differential, they use the wheel brakes, the vehicle's own brakes. So the anti-lock brake and traction control system on the vehicle now is involved with the all-wheel drive stability and traction control system. If the rear tires lose traction, the brakes are pulsed momentarily, which slows down the rear propeller shaft or drive shaft, which forces torque to the front drive shaft and causes the vehicle to move forward. We have left and right tires, or the left tire and the right tire that can spin at different speeds. Let's say the right rear tire lost traction and the left rear tire did not. We can pulse the brakes on the right rear tire, slow it down, and force the torque and the power to go to the left tire that still has traction and get you out of that situation. So the new systems with vehicle stability control and all-wheel drive with an open differential transfer case, or a center differential transfer case, it's basically the same thing. They're open. It's a center differential between the front and rear axles, but it acts like an open differential. We use the brake system to apply or bias torque to the front or the rear differentials. Okay, so this assembly is on, or it's in this output shaft, and so I have another one here that I'm going to insert. So here is our input shaft, output shaft, and then here is an assembled limited slip Zexel Torsen style planetary gear set like I just showed you. This is going to go right here on the input shaft and output shaft at the same time. So let me get that set up. We've got an additional hub that's going to connect in here to send power to the front wheels. So our output shaft is going to connect right into this piece. There we go. Okay, so center differential transfer case. We've got the input shaft, we've got the output shaft. Notice still there is no direct connection input shaft to output shaft. So let me put the output shaft flange on here. I can turn the input shaft over here. There's no power to the output shaft. So we still have a traditional planetary gear set. Here's the sun gear. Here's the planet carriers. The ring gear is up in the back of the transfer case housing. And there is a sleeve, a shift sleeve. Here it is, to connect the input shaft to the output shaft, just like on the traditional transfer case power flow that we looked at already. And so let me get this one connected here. Let's see, we got to have spline teeth against spline teeth. So this is going to go on, or tapered teeth against tapered teeth. These sleeves can be put on backwards quite easily in a lot of cases if they don't have blind splines. This one does. Whoops. Well, let me get this one lined up first. There we go. Of course, it falls on as soon as the other piece falls off. So this sleeve here is going to connect the input shaft to the output shaft. Except notice that it's, well, I guess I stated that wrong. This sleeve is going to connect the input shaft to the center differential. Now the center differential has, like any differential with a left and right side bearing, one of those equivalent side bearings is the rear output shaft. The other one, through this hub right here, is the front output shaft. So if I engage the input shaft to the center differential and I start to turn turn it, as long as there's equal resistance on both the rear and the front drive shafts, they will turn these two pieces will turn the same speed. But if if the front loses power or loses traction and starts to spin, and the rear ends up stopping, notice the front output shaft here can spin real quickly. Or if the rear lost traction and the front did not, let me hold this one, then it can spin freely. So these are just like the left and right axles. And to let me illustrate that a little bit better with another shift sleeve. And the rear output shaft tapered teeth. They're both tapered teeth. Okay. And let me get this bearing up in here. All right, so here is our front output. And there's a shift sleeve here that can connect it to the center differential, so it can spin independently. Oh, and by the way, notice here, if I spin the front output shaft one direction, notice the rear output shaft spins the opposite direction. That's just like an open differential. Same thing if I spin the other one. They always spin opposite directions of each other. So we have this shift sleeve on a hub that when it's back like this, that's the all-wheel drive mode, and it allows for a difference in speed between the front drive shaft. This is where the drive chain connects and goes to the front drive shaft and front axle. Here's obviously where our rear drive shaft connects and goes to the rear axle. On a center differential transfer case, these gears, or this center differential planetary set, allows for the front and rear wheels to turn different speeds. That way, even though you're in all-wheel drive where you have power to all four wheels, you can turn corners and the vehicle will not buck and kick and surge as you're like a typical four-wheel drive vehicle would, because you were trying to force the tires to turn all the same speed. This allows them to turn at different speeds. But this transfer case also has a four-wheel drive high selection. So if we take this shift sleeve and we lock it to the center differential outer housing by moving it back like this, we have now we've now bypassed that center differential. And now, whoops, all of these have to be connected together right there. And now everything spins the same speed in the same direction. And now this acts just like that other transfer case I showed you at the start of this video, where in four-wheel drive, the front and the rear propeller shafts, drive shafts, turn the same speed and direction, and you'll get the bucking and kicking in four-wheel drive on dry pavement, which you should never drive a four-wheel drive on dry pavement. All right, we also have this other sleeve back here, along with this planetary gear set, that comes on here that gives us the four-wheel drive low position. Some will have a neutral position. It still has all three positions. It'll have low if the shift sleeve is back all the way, neutral in the middle, and four-wheel drive high and two-wheel drive high, or just two-wheel drive. Nobody calls it two-wheel drive high when it's forward like this. But we've already gone through the gear reduction operation in the first demonstration I did in this video, so we won't do it here. But I wanted to point out the big difference between a center differential transfer case and a traditional transfer case is an additional planetary gear set. So we've got this planetary gear set that gives us four-wheel drive low and four-wheel drive high and two-wheel drive. We have an additional planetary gear set in the middle that allows the front and rear tires to turn at, or front and rear drive shafts to turn at different speeds. And then you have another open differential in the front axle and the rear axle that allows the left and right tires to turn at different speeds. So a vehicle that has one of these actually has three open differentials in it. So this has been a demonstration and description of the difference between a traditional four-wheel drive transfer case and a center differential transfer case. Have a good day.